Dear third prep, today we will introduce the lesson 3 in unit 4. We will complete the position of a circle with respect to another circle. We have before took the position of a point and a straight line. Now we will complete the position of a circle to another. Here I have 6 positions. Here you remember that we said in the point and the straight line that I have to determine the position with the radius length and the distance from the center to the line or to the point. Here I have 2 circles. So the position here, if it's 2 distance points defined by the 2 radii of the 2 circles. I have 2 different circles with 2 different radii. So if the 2 radii here, their sum is greater than the distance between their centers, so these 2 circles called 2 distant circles. So I determine the position using the line between their centers and 2 radii. If the 2 radii, if this line is greater than the sum of the 2 radii, so I can say that two circles are distant. So the distance here is any number from the sum to infinity. Any number greater than R1 plus R2 gives you a distance circles. So I define this position by the sum of the radii and the line of the centers. I have here the 2 circles M and N doesn't intersect at all, so the intersection between the circles is phi, and the intersection between the surfaces is also phi, and we know the difference between the circle and the surface of the circle. The second position, if the 2 circles come closer to each other, they call touching externally. These 2 circles only touch each other at the point A. You will find that the distance here from the 2 centers to each other is equal to R plus R. If I make R1 plus R2, it will give you the same distance as the line between their centers. So I can say that the 2 circles here are touching externally. These 2 circles intersect at the point A, and their surface also is intersected at the point A. The third position is intersecting, come closer to each other. So they are intersecting circles. Here the 2 circles intersect each other in the point A and B. You see that 2 points A and B here. The point A is the intersection point up, the point B is the intersection point down. So I can say that the length of the distance between their centers is any number between R1 and R1 minus R2 and R1 plus R2, because I have different forms of intersecting. Touching externally, as we said, it's equal to the sum exactly, because I have one position of touching externally, but the intersecting, they could be like this, more intersecting, come closer to each other, it could be more. So I have different forms of intersecting circles. So the number here is can be any number between the difference and the sum. So ME equal the open interval from the difference to the sum between the 2 radii. Here you will find that the 2 circles here, the blue one and the red one, intersecting at the 2 points A and B. What about their surfaces? The surfaces here intersect at the surface of the shaded part, or this area. You can see this part, this area between the 2 circles in the intersection part, and this has no name. The fourth position here is touching internally. If the 2 circles come closer till one get inside the other and only touches at one point A. This position is called touching internally. If you notice that MA is R1, or the radius of the blue circle, NA is the radius of the small one, MN is the distance between their centers. So MN here is R1 minus R2. And the equal because I have no position of touching. This is the touching position. This is no other one. It cannot be different. If say we go out or N, the position will change. So this is the position of touching internally. The two circles here, the blue one and the red one, intersect at the point A, but their surfaces intersect at the small circle N. As you see here, the small circle, all the small circle is common part between their surfaces. The fifth position is one inside the other. Here you will find that circle N is come closer to the center of circle M, or go inside, more inside the circle N. It's called one inside the other, and the distance is smaller than the difference between their centers, or the distance here from 0 to 1, R1 minus R2. Why 0? Because I'm here finding a length. It cannot be negative number. So it could be 0, but not negative 1. The concentric circles, which is two circles have the same center, or the distance between their centers is 0. There is no difference, there is no distance between their centers. I can call this position is concentric. And we will find that in the post positions, one inside the other, and the concentric, the two circles doesn't intersect, but the two surfaces is the smaller circle. The two surfaces here intersect at the smaller circle N. Now, I have now sixth position defined by the difference or the sum of the two radii. Every time I can say that it's greater than sum, or smaller than the difference, or equal to the sum, or equal to the difference. So the position here defined by R1 minus R2 or R1 plus R2. Summary of this here. So what define the position here? 0, the difference or the sum. If the MN equal to 0, they are two concentric circles. If MN equal to the difference exactly, they are touching internally. If equal to the sum, they are touching externally. Any number smaller than R1 minus R2 is one inside the other. Any one greater than R1 plus R2 is two distant circle. Any number between the difference and the sum is for intersecting circles. And we will show it in the example. You will understand more in this example. Here, the radius length of a circle M is 5. And the radius length of circle N is 3. So this is R1 and this is R2. Determine the position of each of them with respect to another circle in each of the following cases. I have here 6 cases and I want to know the position. I have R1 is 5, R2 is 3. I cannot know the position using R1 and R2. I have to find the sum from R1 plus R2 and the difference R1 minus R2. These numbers, which is define the position. Now, I want to know the position. Concentrate on these numbers, not R1 and R2. I have 8, which is R1 plus R2, and 2, which is R1 minus R2, and I have here the distance between their centers. First, Mn equal to 2 is equal to R1 minus R2 exactly the difference. So if the distance is exactly the same, the difference, I can say that two circles here are touching internally. Mn equal 8, which is exactly the sum. So these two circles are touching externally. Mn equal to 0. Equal to 0 here, as we said before, they called concentric circles. If Mn equal 10 centimeters, which is greater than the sum, they are distant circles. Mn equal 1 or smaller than the difference, so I can say that they are one inside the other. And the last position, Mn equal 5. 5 here is a number between the difference and the sum. I can say that these two circles are intersecting. Now, this is how to know the position of two circles. I have to know the distance between their centers, the sum of their radii, and the difference of their radii. And then I can easily know the position of the two circles. I have two corollaries. Corollary number 1 say that the line of centers of two touching circles passes through the point of tangency and is perpendicular to the common tangent of this point. I have something called the common tangent. If I have two touching externally circles like this, the line L here is called the common tangent because it's a tangent for the two circles. So tangent with respect to M, and this tangent of the circle M. This common tangent is perpendicular to the line of centers. Mn here is called the line of centers. So the line of centers here is perpendicular to the common chord, and this is an important mark. And if they are touching externally, also L here is a common tangent for the two circles, and the line of centers Mn is perpendicular to L. Corollary number 2. The line of centers of two intersecting circles is perpendicular to the common chord and bisected. Not perpendicular only, here it's perpendicular and bisected. For example, if I have two intersecting circles like this, Mn is the line of the centers, AB is a common chord. Notice here that AB is chord in circle A, and the AB is also a chord in circle B, M. So AB here, the line of centers bisected and perpendicular to it. And this is also an important corollary and important information because, for example, if I have two intersecting circles like these, A, B, and X are midpoints of the chord CD. A here. So M and N are intersecting at A and B. X is a midpoint of DC. Intersecting between DC and B, A equal E. Measure of angle E equals 60. YF touches the circle M. Find measure of angle Z and X. Z and X, this angle. So I have here a lot of givens. One by one, I have two intersecting circles. It's a given I have to use? Yes. If you have two intersecting circles, as we said in the last slide, therefore Mn is perpendicular and bisects AB. So I have here angle 90 degree at Z, NZA. And from the last lesson or the first lesson, if X is a midpoint of a chord, so NX is perpendicular to the chord, so the angle here NXC is equal to 90 degree. Again, I can use the quadrilateral rule, that the quadrilateral is 360 degree minus 90 plus 90 plus 60, so the angle here ZNX is 120 degrees. Okay, I have another required. He wants to prove that YF is parallel to AB. We said here that MN is perpendicular to AB. And YF here touches the circle means that YF here is a tangent. If YF is a tangent of circle M, so any line from the center to the tangent is perpendicular to this line. So here also MN or MF is perpendicular to YF. And we have studied in the first prep, two perpendicular lines to the same line they are parallel to each other. If you have two lines perpendicular to the same line, so these two lines are parallel. And this is our lesson for today. Thank you very much.